Hello everyone, this is Bronycock, and welcome back to Parity Quest. Today's question is 1/2 even or odd? The answer may surprise you. Now I've gotten the arbitrary clickbait out of the way. Let's just get started, shall we? So, we know that 1/2 time, well, since we're dealing with fractions, probably the best thing to do is a multiplication rule. So if we start off with 1/2 and we multiply it by some number, we can expect, probably the best thing to do would be to multiply it by an odd number. But that doesn't tell us very much. Multiplying by any odd number is just going to give us another fraction over 2. So, what if we multiply by an even number first? Just make sure things are working out fine. Because 1/2 seems to be a pretty odd number. So, let's choose any even number. I don't know, 2. That seems like a simple one. 2 times 1/2. That's 1. So we have an even multiplying to an odd. Well, that's not supposed to happen. I guess it's time to end the series then. I will see you all later, and I'm just kidding. Of course, I wouldn't make a 7-part miniseries if I didn't figure out how to deal with 1/2. But, to be honest, the answer to the question, is 1/2 even or odd, must be no. Which is certainly not something we were expecting. We tried to make parity all even or odd. But perhaps we have to broaden our horizons a little bit. So let's see here. Well, if we consider other forms of 1 over n for a second, obviously if n is even, then if we multiply by n, we're going to get 1. So we get the even times something is odd. So that's not fun. But if this is odd and multiplies to an odd number, this is odd. So, at least we know something. 1 over 2k plus 1 is odd. Okay, so does this follow with the error rules? Well, we just checked multiplying by a odd number. And if we multiply by any other odd number, 2m plus 1 over 2k plus 1, we can just write this as summing 2k plus 1 as 2m plus 1 times. So, if we add all these up, then we're going to get 2 times 1 over 2k plus 1 times m, which we have an even times an odd times an integer, so that's going to be even. And then we have 2k plus 1, so that does appear to be odd. So if you multiply it by an odd integer, you get something odd. So it only makes sense that if we multiply by an even number, we get something even. So let's say that 2j over 2k plus 1 for integers k and j is even. And 2j plus 1 over 2k plus 1 for integers is odd. And we'll come back to that one nagging case later. We don't have to consider evens over evens because that'll always reduce to one of the error cases, and I wrote even, so there's that. So you can start adding these up if you want and just trying them. For example, if you want a simplification, do 1/3 plus 1/5 is equal to 8 over 15, which is indeed even. And you can check this for pretty much all of them. It's going to give out the right value. But what about that question we started with at the beginning? If we have evens and odds, then what's left? Well, if we can't use even and we can't use odd to describe 1/2, we'll just use something else. Occam's razor, it's the simplest thing to do. So, we have 1 over an even. So it's like the inverse of an even. So we are going to call it, well, we could write backwards and call it Neve, but I don't like how it sounds. So we're going to call it Steve instead. The answer to what is the parity of 1/2 shall now and forever be Steve. In fact, anytime you have an odd over an even, it shall continue to be Steve. And if you multiply by evens, it gets weird. 2 times 1/4 is 1/2, which is still a Steve. 1/4 times 1/4 is 1, which is odd, and 8 times 1/4 is 2, which is even. So, multiplying by an even doesn't really tell us much of anything about the general Steve. To be honest, it might help to come up with some way to classify them. Yeah, that'll work. How about we call it a first order Steve? If 2 to the 1 times our Steve is odd, we call it second order if 2 squared times Steve is odd, and so on and so forth. So in other words, you can check this. This is odd divided by 2, so it's 1/2 times some odd, and 1/4 times some odd, and so on and so forth. Nth order Steve is 1 over 2 to the n times some odd fraction. I would not recommend mixing in the square roots we worked with last time with this for reasons that will become apparent much later. Or if you work it out on your own, you can find some weird stuff going on. Anyways, that about covers the stuff I wanted to talk about, but I'll leave you with this tidbit. 1/2 plus 3/2, both first order Steves, adds to 2, which is a even number. But 1/2 plus 5/2, two other first order Steves, adds to 3, which is an odd number. So how does addition among the Steves work? See if you can figure out a consistent system and join me back in 2 weeks when we cover that. And don't forget to come to next week when we start talking about something that isn't as hard as this to figure out, but probably comes up with a even less satisfying no than we had this time. So don't forget to join that one. That sounds fun. Anyways, like, comment, subscribe, etc., etc., share with your friends. Or, just watch the videos. I don't really care. Anyways, this has been Brony Calc, and I will see you all next time.